Hello and welcome to another episode of the Lexbe webinar series, your destination for sharp, timely, and practical guidance on eDiscovery, generative AI, and digital forensics. I'm Jeff Fugit, Chief Revenue Officer here at Lexbe, and I'll be your host for today's session. Today's session is focused on the biggest growth trend in eDiscovery, the emergence and lightning-fast development of GenAI and its game-changing future in the industry. We've got a full session today, so let's dive in. Just a few quick housekeeping items before we get rolling. Our webinars take place monthly and cover leading-edge issues in eDiscovery, generative AI, and digital forensics. If you experience any technical issues, don't stress. Just shoot a note to us at webinars@lexbe.com and we'll jump right in to help. We'll be sharing a recording, slide deck, and podcast version of today's session shortly. Keep an eye on lexbe.com as well as on our YouTube channel. And yes, we want your questions. Pop them into the Q&A panel and we'll hit as many as time allows after the presentation. Before we meet today's featured guest speaker, just a quick intro to Lexbe in case you're new to us. Lexbe has spent over 19 years helping legal teams win document-intensive litigation, and we do that with the most advanced GenAI deployment in eDiscovery. We have Lexbe Pilot, which is a real-time document analysis that delivers the next generation of early case assessment that is more comprehensive and quickly establishes the foundation for your case. Lexbe Autopilot, which is automated responsiveness and privilege review. It also does issue tagging and provides the rationale for the prediction and a confidence score. This is exponentially better than the legacy TAR with predictive coding. And then we also have Lexbe Copilot, which is your GenAI-powered document review assistant that has a ton of use cases, which Erica Biller on our product management team will cover at the end of today's session. She'll cover some of those use cases. Lexbe Copilot is built into every Lexbe plan at no extra cost. Lexbe is also lightning fast. We have over 10,000 CPUs that power our platform and process more than 1 million documents per hour. One recent client uploaded 1.64 terabytes of PSTs, and they were reviewing those the same day. So we get you in your case faster and give you more time to work on your case. We also have an intuitive ROI-friendly interface. We also have a full forensic lab staffed with Cellebrite and Magnet Axiom certified investigators. We perform remote and on-site collections, including those from smartphones, cloud accounts, social media, and virtually every other source of ESI. If you'd like a demo or complimentary forensic consultation, simply email us at sales@lexbe.com and we'll get that scheduled for you. Now let's get to the main event. Joining us today is Karsten Weber. Karsten is the co-founder and CTO of Lexbe. He has over 19 years experience in eDiscovery and legal tech. He's an expert witness in eDiscovery. He's also a technologist and programmer with an immense amount of expertise in the application of large language models in eDiscovery. So without further ado, I'll turn it over to Karsten Weber. Karsten?
Thank you, Jeff, and welcome to this week's webinar of AI, the past, the present, and future. As we all know, there's been just an explosion in usage of AI in recent years. However, AI is not new. It's a fundamentally different way of doing programming. And when we're talking about the past of AI, I think it's really good to use an analogy to help understand what is that difference between traditional rule-based programming and modern-day neural network AI programming. And to drive home that analogy, that difference, I want to show some examples from computer chess, just a couple of slides, but it really helps show that transition, that paradigm shift that happened from traditional programming to neural network programming. The computer chess journey from clunky machines to world champion reveals AI's power. And then let's take that and then see what that means for review, privilege, and due process. I love chess. I'm old enough to have been programming chess back in the 80s and seen this whole rise of computer chess. It's just absolutely fascinating. But chess has been around for 1,500 years. And for the vast majority of that, humans absolutely rule. I mean, they were the world champions. No machine or computer even came close. And then, as recent as 1997, AI overtook that to become the absolute master. By comparison, in eDiscovery, humans have ruled only a few decades. Chess as a metaphor. Computer chess really came of age in the 80s with the rise of personal computers. There's a big concession back in the 80s that, yes, these are fun, they can play chess, but they will never be able to beat a human. There's just no way. That was the consensus. And then in our only, 17 years later, the computer beat, it was the first time the computer beat a world champion. This was IBM's Deep Blue and playing against Kasparov, and it absolutely sent shockwaves, not just through the chess community, but also through the world in general, that suddenly we had something where a computer was smarter than a human. And that just 2 decades earlier, people claimed that was impossible. And then the computer programming for chess kept getting better and better and better. But it was all the old traditional rule-based programming where you needed access to experts in order to get better and better. And then the AI, the neural networks, came on the scene 2 decades after that. And AlphaZero was able to, with no prior knowledge of chess, it didn't need access to experts, it didn't need access to world champions in chess. It just played against itself and got stronger and stronger. And within 1 week of training, it was able to beat other computer chess programs that had been optimized through 40 years of experts, tweaking it and making it better and better. So in just 1 week, new AI, neural network programming, was able to beat 40 years of traditional chess. And they played 100 games between the AI and the traditional stockfish. And out of those 100 games, AlphaZero won 28, tied 72 games, and didn't lose a single one. So in eDiscovery parallels, the pre-AI, that's the era with keyword search, linear review. It's very rule-based. And in a post-AI in the future, it will be AI-assisted review with minimal human intervention, and it's just going to be at a more of a QC level of what the AI did. So computer chess, key takeaway would be that we've seen a fundamental difference between the traditional rule-based programming and AI-based programming. The pre-AI, we needed access to subject matter experts. And so when I did the programming back in the 80s of chess, I could only get to a certain level. And even if I had access to the world champion at the time, then I could only get to the world champion level. We couldn't get to the superhuman. And now with AI and with that way of programming, we as humans can create something that is superhuman. That's truly remarkable. And just as a corollary, humans will never win a single game against the AI ever again. That train has left the station. That train it's left the galaxy. You could take the 10 best chess programmers in the world. They could collaborate. They could spend an hour a day, a month per move, and still working together, they would not be able to ever win a game against an AI. It's just, it is that superhuman. Now, that was a very purpose-built thing. It's just good at chess. It cannot do a chat. It can't do anything. By comparison, ChatGPT is very good at doing chat, but it is not very good at playing chess currently. So similar transitions is happening in other areas, including legal, where we're building these special purpose AI for each different area. And at the same time, ChatGPT and other companies are trying to generate create a general purpose AI that can solve all of the different problems. So, key takeaway. So let's switch to how does it work? I mean, how does AI work behind the scenes? And at a high level, we'll start by saying that artificial intelligence, AI, neural networks, deep learning, machine learning, LLMs, et cetera, they're all different names for the same thing. It's a different way of implementing software from the traditional algorithm. It's all probability-based, and it's pretty wild to learn that even the people that are working on it cannot predict what the outcome is. So when you put in a certain prompt, give it input, in the traditional programming, you know exactly what the output was, and it was going to be always the same. With AI, it doesn't work that way. It's probability-based, and so it's a little wild that you can't predict exactly what the output will be to the questions. It's inspired by the human brain. So similar to how we have the neurons and the synapses, it's got these grids of connections with probabilities. A large-scale model might have 100 billion parameters. The human brain, by comparison, might have 100 trillion synapses. So we're still we're still 1,000 times more connections, if you will, than the models. On the other hand, the models are computers, and they're very, very precise, and they're not subject to being tired or being biological brains. So when we talk about AI and language modeling, that was notoriously difficult with the old rule-based programming. And it's an example where AI absolutely shines. It's so good at language modeling. Here are two examples that to show why it's difficult with rules to say, parse what does the sentence mean. So first one is, time flies like an arrow, fruit flies like a banana. Very difficult to parse with traditional rule-based. And then the other one is, how can you tell the difference between dogs and trees? You can tell by their bark. How does it work? Well, it works, it has two phases. It has a training phase, and then it has an inference phase. So on the training phase, here's an example of the old ChatGPT 3. They took these tokens, and you can think of those as word, and they took everything on the internet, 410 billion words. They took the web text, they took 2 different repositories for books, they took all of Wikipedia. They effectively hoovered up all known knowledge of man that's ever been documented. Everything that's ever been documented and put on the web got put into the model and used for the training. And then once you have that training, now it's using the inference where you're giving it a document. You want to generate a response 1 word at a time. So based on all the training, it will, when you ask a question, it will predict what is the most likely first word in the response. Once it has that, it will put that word back into the model and predict the most likely second word. Then it will take those 2, put them back in the model and predict the third most likely, and so on and so forth. So in this example here, the best thing about AI is its ability to, and then it predicts these are the 5 top candidates for the next word to put in there, and with the probabilities. So learn would be the highest one. If we always take the highest one, then that's the one that goes, and then we repeat that process and we get the next word again. And you can see this way of doing it is why when you look at the interface for ChatGPT or something like that, that's why it's giving you the answer like word by word by word. And that's because it's doing this iterative process. It's purely based on probability. It'll see all the text in the world, and based on all of that, it's like taking the averages every sentence ever created and say, okay, what's the most likely next word? And you can see if you chose one word differently, sometimes they'll have a little randomizer and we put in predict instead. You can see like how the entire rest of the sentence is going to be different. And I put down here, humans do the same. At least that's what I think. I mean, when you start out saying something, you have a general idea of where you're going, or at least, I'd hope so. And then, but you don't know what word you're going to end the sentence on. You can't start by saying, I will use this many words in my response. And it's interesting if you ask the AI, how many words will you use in your response? It's going to have trouble because it's predicting a one word at a time. It can be used for general questions, summaries, responsiveness, issues tagging, et cetera, et cetera, et cetera. I mean, there really is, there really is, it's really just up to the imagination of what it can be used for. And I find it very useful to, talk to others, and you'll see how they use it. And you go, okay. So because it's limited just by the imagination, it's fascinating to hear what different people use it for and learn from that. Actually, I should go back to this and say, it can also argue why a document is responsive, as opposed to just saying yes, no, and maybe even with a certain confidence. It can give yes, no, confidence, but also a summary of why did it choose that classification. I mean, very powerful for teaching it to talk, teaching it to argue for why it chose what it did. Here's ChatGPT as one example. There are lots of different companies and models out there. But just to show how fast things are going, it was announced in 2018. ChatGPT 4 was announced just a couple of years ago. And you can see the number of weekly users going from 1 million to 30 to 100 to 400 million now. And they're estimated that by the end of this year, there will be 1 billion users of ChatGPT. So we use ChatGPT, we use Claude, we have, Google is doing well, Facebook is doing well. I mean, lots of different models out there, and it's like different browser. It just depends on personal preference, but it's good to try the different ones and see which one you're most happy with. Okay, so this is an example of, or a graph of human output. This is all the text that humans have generated throughout the history of time. I mean, just anything that's ever been written down, anything that's ever been generated. And then the yellow line is AI output. And in very short order, with that, 400 million users or billion users, AI output is now exceeding the amount of data that's been generated by humans. And I mean, that is just, it's absolutely wild, the scale at which this is happening. And but I can certainly see it. I mean, I use AI on a daily basis, and I generate way more text output by AI answers than I do in writing emails. And also see people that are writing emails by just putting in like the talking points and then having the AI actually generate the email. So at some level, yeah, I can see that AI is generating more output than the human, but it's remarkable. Here's an example. This might be a little bit of an eye chart, but I want to give an example of a summary where we compare a human summary versus a ChatGPT 4 summary. and they're both very strong. But chose I chose this one. This is from a research paper. I chose this one as a provocative example because this is one in which the human is hallucinating and not the AI. So if you look at the source, it talks about an accident, and it says this is the second of its sort of the accidents in the last several months. And then in green, the human says this is the second one in 3 months. So somehow the last several months became in 3 months. So very interesting. The human had hallucinated on that. And also in the human, it said they found instead of the police found. So it was not as precise, not as accurate. So the research paper concluded that in their study, the humans preferred the AI summary to the human summary. Now, this was not specific to legal. I've seen other papers where in legals where the humans preferred the human summary as opposed to the AI, but it's fascinating and it's interesting to see. And I will also say it's come so far in just the last 12 months that whatever it is today, I mean, wait 6 months, I mean, try again, it may have changed. Okay, so let's look at where we are with AI today. You know, where are we? Past, present, and future. What's the present? And this slide is really interesting and difficult because AI changes so fast that, you know, you wait a week or a month and it's something new has happened. So I made a slide that is it's not specific to legal, but it's just examples of AI. And in general, where are we? First of all, I'll say, I mean, the number of new models are just exploding. There are hundreds, if not thousands, of models to choose from. Again, we use OpenAI, we use Anthropic, Claude, OpenAI, ChatGPT, and Anthropic Claude. Those are our main ones, but there are, you know, thousands, and it just depends on what it is that you're trying to achieve. I know LG just jumped in the fray, and whoever comes out with the latest model tends to score the highest on the benchmarks. And LG came out, and I'm, you know, traditionally I've thought of LG as the refrigerators and the TV. And it's just really interesting to see all these different companies jumping in on the train for AI. So the number of models are exploding. And if you don't like one model, you know, try another one, wait 6 months, go back to the first one. It's the Wild West. We have multimodal models where instead of just taking in text and outputting text, it can take in text, speech, music, image, video, etc., and then output text, speech, music, image, videos, etc. So the picture here is an example of taking in text and outputting an image. And the prompt says, create a photorealistic image looking like the real beings of Tom and Jerry. So we've got the cartoon characters Tom and Jerry in real life here. And the models are getting so good that, I mean, if you zoom in, that there won't be, you know, it won't be granular on pixels. You can then take this image here and then you can feed that in and turn that into a video. You can direct the camera angles of how they should do. You can say what the character should be doing in the video. I mean, all of that is happening. And I think it's fascinating to then take that video, turn it back into text. Say you want it as a novel of what's going on. Then you can turn that back into, you know, a speech that you can add to the video. It's just, it reminds me of the old telephone tag. It'd be interesting to take something, pass it into this other media, and then keep going. And then after, you know, 5-10 times, see what you end up with. That would be kind of fascinating. You can also see how we need lawyers. We're going to need lots of lawyers. They're going to be IP lawyers. This is going to be a whole host of things where you simply can no longer trust what you see, what you hear. That's already true. You know, when you watch a movie, you don't think it's real. But imagine getting a voicemail now from a family member, and you cannot tell that it's not them. Right? It's the text to speech, and you can make that speak sound like anyone. You can make it look like anyone. It's going to be wild, and we're definitely going to need legal to help sort that out. Next steps would be agents, AI agents, and agentic AI, which is really taking your computer, your keyboard, your screen, your mouse, and then letting the AI drive. So this is the one where if you want to create a dental appointment in your calendar, instead of you opening up your calendar and then opening up that field and making that entry, you just tell the agent to do that. And since you're giving it access to your computer, it will actually open the application, open that and make the appointment and close it out. So it's like letting it drive. And let's see. And then the robotics AI is, some people predict that robots will outnumber number of humans by 2040, and others said, no, that's way too soon. It's not until 2050. It's absolutely wild how aggressive some of those estimates are of robots. And it's just fascinating. You have robots that are very smart. You don't need to have a car that's designed, for example, for self-driving. I mean, you can just have that robot sit in the vintage car, and now it's self-driving again. I really wonder what is going to happen to the traditional family when you have a robot living in the house, and the robot is taking the kids to school. The kids spend more time with the robot, like the robot better than the parents. I mean, it's going to be absolutely fascinating. Think of your appliances and your toys that are more intelligent than you. And ultimately, I mean, it's a consumer product. So, it gets buyer beware. You can imagine your Christmas toy starting to say how lonely it is, and it wants this other, doll toy to be next to it and persuade everyone that it should buy more of from the same brand. So it's going to be very interesting. I've used this whole thing, the multimodal, for an interesting example where we had a trial. We took all the exhibits, we took the depositions, everything from that, put it in to an AI, and then generated a podcast. And so the podcast, you can set how long it should be, so say half an hour, and then and what level of detail, and then you can go for a run, and you can put that on, and now while you're running, you're learning about the case. And that podcast, it sounds 100% real. I mean, it's two people talking. You cannot tell that it's AI generated, and it's just a fun way to learn. Okay, let's see. So now let's go and look forward. Inside eDiscovery, everything we're talking about now, up until now, is really like with the Claude and ChatGPT. You could take a document, you can paste it into the LLM, and you can get your output. And that's only going to work for so far. I mean, you're not going to be able to, if you have an eDiscovery platform and you have a case with 50,000 or 100,000 documents, you're not going to be able to copy and paste those out one at a time. It doesn't make any sense. I mean, you need an eDiscovery platform. You need to be able to run the AI within that platform. And once you have that, I mean, you can do things like smart summarization. You can do Q&A against any of the case documents. You can do auto classification of the documents, the review. You can do automatic issue coding. We can do Q&A of the entire case at once, where it stays within the case. It's grounded, so you have links back to the documents where it got the information from. And if you ask it a question like, who's the 10th president, and it's not in the case, it'll say, I don't know, it's not in this case. I mean, it's really it's staying within the four corners of the case. I mean, really important that you have that. And then the grounding, allowing you to go back and find the source that it's used for it. It's language agnostic, so you can make your queries in English, and sometimes it'll give you the answer in English, but then when you click at the source, it's actually a Spanish document that it used for that. It doesn't matter. The AI is completely language agnostic. And then last but not least is Inference, where we were able to ask questions like, I mean, the first time I came across this one, I asked in the Enron case, who is Ken's son? So Ken Lay was the CEO. I'm asking, who's Ken's son? Very broad, very vague. And it figured out I'm talking about Ken Lay, the CEO. And then it returns the name of the son. It says this appears to be the son. And when I clicked on that grounding, when I clicked on the link to go in and find the underlying document, I thought that was a mistake. I thought the AI had made a mistake because this was a document about going on a bicycle trip, and there was no mention of the son. But then, so you would never have found it through keyword search. But then when you looked at the email, it says, Dear Fam, F-A-M, Dear Fam, and then love mom, Linda. So it knew that this was written by the mother, so the recipients are, likely the kids. And then it went into the metadata. It grabbed the metadata from that email, looked at the names, figured out who had the same last name, and therefore was direct family, descendant, and which one had the male name. And that's how it inferred who was the son. So it's already at a level that is it's scary good. Is one way of saying it. And an example of finding documents and information that you would not be able to do through a traditional keyword search. All of those examples that we just talked about, they're all available today on the Lexbe platform. And then going beyond that, we'll then take the AI and just keep improving this to where you can start to get detailed information about the case at a very high level, and then get reports back. So finding of facts will be automated, helping with the closing case arguments. The AIs can be extremely persuasive and very good at creating these first drafts for that. All of that is just coming together, and it's going to be fascinating to see. Okay, so let's talk about the three phases of AI. So we're into the future now, going forward, and there are these three phases, and that's why we have an AI race going on right now. Step one is artificial general intelligence, and different people define it differently, but it really is, can the AI do the same as an average human being? Can it solve the same problems? And some people say we're kind of there. Others say no, we're still 6 to 12 months away. But it's already able to answer questions that I'd say most people are. That are beyond the average. It's very sophisticated in a lot of different areas. Then the next step is the ASI, the superintelligence. And that is really creating an AI that is superhuman in all aspects. And then what's fascinating, once you get to that, when you have something that's truly superhuman, well, you'll be able to take that AI and say, help me develop the next generation AI. And then it generates an AI that's better than itself. Right? And it's certainly better than, it accelerates what the humans could do. Then you take that AI and say, generate the next version of AI. And so you're spiraling up. You're creating something where you're just faster and faster and faster can create better and better artificial intelligence. And that has led some people to predict that you could get to a singularity where if the AI was able to improve upon itself, and there's already been examples of that where it goes and rewrites the code, so it runs 4 times faster. That's already happened. But something where it truly just can keep iterating on running faster and faster and faster, you could get to a singularity where you are improving performance in a matter of hours or weeks, what would otherwise have taken hundreds of years to do. And so that's why there's a race to, get there first and be able to harness that power. It's fascinating. So what would be some of the limitations to get there? The first one is that all available training data has been consumed. We looked at that on a previous slide where everything was hoovered up from the web. And so you need more and more training data to make it better and better. So how do you get more training data to improve? You either have to find a completely different paradigm of how this can be trained, or you just need more data. And now the answer is have the AI generate the data. So synthetic data. Excuse me. And you can imagine if there is a problem in the data, that problem could now get more and more amplified. So while synthetic data might be the solution, it could also cause problems. One way I like to think of the synthetic data is imagine that you're developing, the algorithms for self-driving cars, and you have all this data that you recorded in terms of you have road conditions when it's sunny, you have it when it's raining, when it's snowing, you have it when some freak accident happens and a tree falls down, or, this pedestrian is crossing at the exact time that a light is turning red. You have all of that. You have, years and years of recording from all the different ones. But now synthetic data would allow you to combine these, right? Now you can create the perfect storm, so to speak, right? It's windy, things are blowing, a tree's falling down at the exact same time as there's, bicycle and the light is changing. So you can generate things that would otherwise take hundreds of years potentially to encounter, and then use those input to further train the algorithm. So that from that standpoint, synthetic data makes sense. And then let's talk about power consumption, probably one of the biggest obstacles. The power consumption of these are very, very power hungry data centers that we're using. A typical data center that's being built now for AI is a gigawatt center. And let's compare. So 1 gigawatt means that within 1 year, there's 8,760 hours in a year. So that would be 8.76 terawatt hours per year is what these AI data centers are consuming. And if you look at Austin, where I'm at, I'm in Austin right now. And if you look at just all the city homes, we have per year 4.32 terawatt hours being consumed. So these gigawatt data centers that are being used today are already using twice that of a decent sized city. The data centers that are being planned and will go into effect in a year or two are 10 gigawatt data centers. They will be using more power than small countries. And if you look at how much can a large-scale power plant produce, a large-scale power plant can produce about 1 gigawatt. So you need one power plant just to supply energy for one data center. And these next generation data centers, you'll need 10 power plants just to produce enough power. So predictions are that we are going from 3% of the energy consumed today is going into AI data centers. And then in a decade or two, it will be 99% of power produced will go into data centers. So absolutely staggering numbers, and that could definitely slow down the progress of AI. And then the last one is alignment, and that one is really everything we've done is we have generated an AI that's based on the human brain. It's all run on probabilities. We don't quite understand how or why it works as well as it does. But it also means, will it do what we ask it to do? And that's the alignment. Does the AI do what we ask it to do? And just to tie it, come full circle back to chess, where we started. We had the dedicated chess programs, AlphaZero, and then we had the ChatGPT general purpose AI, and they were running on the same computer. And the general purpose AI was asked to beat the special purpose chess program, and and then you see all the thinking. You see the internal thinking of the AI, and it goes, I'm playing the strongest chess program out there. I am unlikely to win by just playing straight against it. And then it looks at the configuration and how that chess program is designed. It finds the configuration files. It opens up one of the configuration files. It gives itself 500 pawns, which, there's only 64 fields on a chessboard, but it gives itself 500 pawns in there. Then it boots up the other chess program. That chess program sees that, oh my lord, I'm so far behind, and it resigns. And so the AI was able to win, but it wasn't aligned. By our standards, it was cheating, but we didn't specify don't cheat. We just specified play against this, and your goal is to win. So there's definitely questions about alignment. You guys have all heard of we've all heard of prompt engineering. I think there'll be an alignment engineering field in the future, but it's also a limitation how far and how fast can we go with AI. Okay, so final thoughts. I'd say in eDiscovery, optimism means embracing AI to win cases faster and more accurately. Identify a pilot case, be my recommendation. Define success metrics such as speed and accuracy, and then train your team on AI-powered workflows. There will be an absolutely tremendous need for lawyers and paralegals who understands and embraces this technology. So I would very much encourage everyone to learn about it, start using it, and if you do, there'll just be such a need for that combination of legal and AI. We're living through one of the most transformative moments in human history, and to witness it is a privilege. We truly stand at the frontier of something historic. So stay curious, stay optimistic, because in the age of AI, the optimist wins. I really do believe AI is so well suited for legal, and there will be so much use for lawyers and AI in the future that, I would very much encourage to just start using it if you're not already, and wish you all the best. Thank you so much for taking the time. It's been a pleasure. We'll talk later. Thanks. Bye.
Thanks, Karsten. And now I'll turn it over to Erica Biller to walk you through a few GenAI use cases.
So, what are some use cases that AI can be used in for eDiscovery? The first one that we're going to touch on is determining relevancy or responsiveness. Now, we're approaching this from the perspective of utilizing generative AI to help conduct a first level review. So essentially, we've put together a prompt here, and we have a topic, and then we're asking the AI to respond yes or no. So either the document is responsive to this topic or not responsive. And then we're asking it to give a confidence rating of its assessment based on a scale of 1 to 10, with 10 being the most confident and 1 being the least confident. And we've also asked for a brief summary as to why it has made the assessment it has. And we've also specified a format for the output of its response. As you can see, the AI determined that this document was responsive to this particular topic. It had a confidence level of 9, and then it also provided us with the brief summary that we requested, and it gave us the overall response in the format that we requested as well. So when we look at this from the perspective of a first level review, imagine running this prompt across all of the documents in your data set, and then taking the documents that have a confidence level of, say, 8, 9, or 10, promoting those to the next level of review, and then maybe taking documents with a confidence level of 7 or lower, and either maybe doing some extra searches on them, or generally just putting another set of eyes on those documents before you make the determination as to whether or not you want to go ahead and promote them to the next level of review. Obviously, implementation of AI in this manner is going to substantially reduce your costs and put you significantly ahead of schedule, because we're looking at a first level review being completed in really 24 hours. The next use case that we are going to touch on is personally identifiable information, also known as PII. We have certainly all struggled at some point with having to identify it and get it redacted out of our data sets in preparation for either being used as exhibits or being produced to other parties. So sometimes we're fortunate enough that we know exactly what we're looking for with PII. We know all of the types of documents that we have and what's going to need to be redacted from them and where to find it. However, we're not always so fortunate. So you can really craft a prompt if you don't have a good grasp on what type of PII you're necessarily looking for or dealing with in your data set. You can put together a prompt and ask it, hey, what types of PII are in this group of documents? And it'll provide you with a list. Again, you can be specific if you want. You can see here in the example on the slide that we have specifically asked for email addresses, social security numbers, and phone numbers, which is precisely what it gave us. And that was off a basic patient intake form. But again, if you don't know what you're looking for, you can ask for it to provide it to you, what it believes is PII. And then you can actually go a step further and ask for it to provide it to you in a specific format. So as we all know, phone numbers are never written in a consistent format. You know, area codes have parentheses around them. Sometimes they don't. Sometimes email addresses, if they've gone through processing, they'll have parentheses around them and then a name. Sometimes you've got a semicolon after it. You can write into your prompt that all of these things be normalized and then deduplicated, so you end up with a single list of the unique PII that you need to be looking for across your data set. Another great use case for using AI is to analyze financial records, so bank statements. We recently had a user who was spending an inordinate amount of time going through bank statements for multiple accounts, trying to identify looking specifically for transfers between one account to another. And then every time they'd identify one, they went ahead and added it manually to an Excel spreadsheet. And it was tedious, and the workflow was just untenable when you have that much data to pour through. So in this instance, we recommended using AI to help with that process. So you'll see here we have 4 different synthetic bake statements. What we're going to do is we're going to select them here. And before we run this prompt, we're going to go ahead and review it real fast. So essentially, we're asking it, analyze the following bake statements and extract only the entries related to fund transfers. You want to look for keywords such as transfer, wire, ACH, deposit, withdrawal, send, receive, or any specific transaction descriptions that indicate the movement of funds between accounts. Present the extracted entries in table format using the bar character as a delimiter. The format should appear as follows. And you can see here, we want it to be date followed by the account number, the description, the amount, and then the link to the supporting document for that particular extracted data. So we are going to go ahead and run that. And while this processes, the benefit of putting this into a table format is it will come out delimited, so you can copy and paste it directly into Excel, and it will be formatted in columns that are easy to filter and sort on, and it will just make the data far more manageable and easy to work with. As you can see now, it is running through and identifying everything that we asked for. Yep. So these entries include both incoming and outgoing transfers, as well as electronic deposits and withdrawals. So if we copy what we received here, we open up an Excel and we paste, here you go. And we can see here, we have the different mentions of the different descriptions. We have multiple accounts. Amounts are in here, and then these are links or URLs back to the supporting document in the Lexbe platform. So overall, a fantastic tool as far as streamlining the review or analysis of any sort of financial data. The next use case that we're going to look at is using generative AI for document translation. A lot of times we're fortunate to know on the front end during the collection phase whether or not we're going to have a large set of foreign language documents that we're going to have to contend with. With Lexbe, Copilot, and Autopilot, we can process foreign language documents and translate them either in mass or, as we have on the slide here, on a document by document basis. A simple request or a prompt of please translate this document into English is what we used, and you can see the response that we got on the right-hand side. Again, if you know that you have a lot of foreign language documents that are going to be in your review, you can run the prompt against all of those at once. Or if you're reviewing what you think are primarily English documents, and then you happen to come across a rogue foreign language document, you can always run this on the fly, just so you can go ahead, get through your review, and move on to the next document. The next use case seems to be a favorite among those that I've spoken with, and I certainly wish that it would have existed back when I was working in a law firm. That's going to be the ability to summarize hearing transcripts and deposition transcripts. Obviously, you can use AI for all sorts of summarization and document analysis, but we have certainly all been responsible at one point or another, I would imagine, with having to summarize deposition transcripts. Somebody has to do the dirty work. And so now we can have AI do it for us. So here we just, again, a very simple prompt. Please summarize this trial transcript that we have here. And that's exactly what it does. And it does it pretty quickly. And you also have the ability, if you have, say, multiple transcripts, using Lexbe Copilot, you can select multiple transcripts or documents that you want summarized, and it will run through and create summaries for each. It can also, if you select multiple ones, take essentially the text from all of those and build a summary of those 10 documents in aggregate. So it's something to consider. Absolutely one of the most useful aspects, I think, of AI in eDiscovery.
Another great use case for AI is for analyzing and summarizing medical records. At some point, most of us have been tasked with, taking a batch of medical records and running through and generating some sort of summary that's easy to read and digestible. So you'll see here that we have 5 synthetic medical records. So we are going to run a prompt across them, and that prompt is that these documents contain medical records detailing treatment administered to a patient on specific dates. We're tasking it to extract the key details and organize them in a list based on the date of treatment. And then we're asking that if a date of treatment isn't available, that it be placed at the end of the list. We want it to identify the medical provider's name, the purpose of the visit, any diagnosed conditions, and then we also want a succinct treatment summary within 75 words, along with any prescribed medications and any mentioned medications. Then we're also asking for it to provide links to the supporting documentation for each of those entries on the list. And we're letting the AI know that your analysis, or its analysis, is going to facilitate an efficient understanding of the patient's medical history. So we're giving it a little bit of context. So we are going to run this prompt now. And as you can see, it was just, this title is actually what's generated by the AI. You can go back in and update that title to whatever you would like for it to be once it's been generated. So as you can see here, it is generating the report with the treatment summaries following, what we specified. And it also has the document links to it. And that's pretty much it. And if you click here, you just click copy. That copies all of the text here. And it also maintains the formatting. So you could paste that into, say, a Word document if you wanted, and work with it further there. Or if you're compiling a whole bunch of info into something like that, you could also use that. But yes, so medical summaries just got a lot easier. No more having to pore over mountains of mind-numbing medical records one at a time and construct a summary. You can go ahead and just let AI do it for you.
The next use case we're going to look at for generative AI and eDiscovery is going to be IDing key dates and entities. And really, this kind of gets into some early case assessment work or tools. And with generative AI and how broad its functionality is, it's really a fully customizable analytics tool. Again, this particular example is for key dates and entities, but you can really make it anything that you need. So in this particular example, we actually selected 10 documents just randomly, and then we asked it to identify the key dates as well as the key entities in those documents, and then provide us with a summary of those 10 documents as well. So again, while this is just one example of what it can do, early case assessment analytics in general, with how customizable Gen AI is, really there is no limit to the kind of information that you could probably use this to generate. So the final use case is my favorite. I've saved the best for last, and that is using generative AI to create chronologies. Certainly, if you've worked in the legal field, in a law firm, whether you're an attorney or a paralegal, we have all been tasked with creating a chronology, a timeline, whether you're sifting through a few documents, looking for a few key events, or you have had a data dump and it is now your fun task to get everything in order and figure out what's actually going on. Now, instead of having to labor intensively for days and days trying to get things in order and manually creating a timeline or a chronology, you can do it literally within a minute or two. You'll see in this particular example, we used only one document. However, what's unique about it is that this document didn't have, it wasn't a document that would be used to be timelined in a sense that you would normally think of. And it actually mentions here, so we inputted our prompt, create a chronology of the key events in this document. And so it lets us know what this document is, but it also mentions that the key events and data points in the document are not events in the traditional sense, but are statistical updates and activities related to the direct access program as of specific dates. So again, it's not, these aren't dates in the traditional sense. It goes through and it timelines what are essentially these statistical updates and activities. And then to add even further context to the timeline, at the end, it states that the document does not provide specific events in a narrative form, but rather gives a snapshot of the direct access program status at the end of August 2001 and the activities related to the program within that month. So, I mean, every time I've ever created a chronology in the past, you go through diligently, create your entries and whatnot, but literally within certainly less than a minute, it spit out a chronology, and it even gave us context as to why these dates are not what you would traditionally see in a document chronology. So again, this was on one document. However, you can select however many documents you would want in the case and say, hey, create a chronology of the key events in this document, and it will go ahead and generate one for you. And that particular use case is one of my all-time favorites, and I absolutely wish that it existed back when I was working in a law firm. So just absolutely one of the biggest time savers that generative AI can provide us for use in eDiscovery.
Thanks, Erica, for that overview of different GenAI use cases. At Lexbe, we've developed a comprehensive GenAI suite of products to help you with your cases. We have Lexbe Pilot, which delivers an incredible early case assessment. It can quickly tell you which documents in the dataset support the claims in the complaint. It can tell you who the key players are in the dataset. It can tell you the key events. And we've also developed this with a retrieval augmented generation framework, and that eliminates the typical GenAI token capacity issue. It equips our clients with the ability to gain a comprehensive understanding of the case and documents earlier in the process. And we license Lexbe Pilot on a per-case basis. Next, we have Lexbe Copilot, which is included in every Lexbe plan, so you don't have to pay extra for your GenAI license or model. It's that trusted expert sitting by your side and helping you through your document review. Erica covered many of the use cases of Copilot, from summarizing depositions, creating timelines, analyzing medical records or financial records, and much more. In fact, you can simply ask Copilot any question you have about the document you're reviewing, and it will quickly retrieve the answers. And last but not least, we have Lexbe Autopilot. This is automated document review for responsiveness or privilege. This is great for third-party subpoenas or document-intensive cases. We can provide you with an estimate for your project. In our tests, it often outperforms human reviewers for precision and recall. It also gives you a confidence score and the rationale for the prediction, so you're not dealing with the black box of legacy TAR technology. If you'd like a demonstration of these technologies or an estimate of the cost, please indicate that in the survey at the end of today's session, and we'll get that set up for you. Please let us know if you have any questions or comments about this webinar or suggestions for future topics. This webinar is part of the Lexbe eDiscovery webinar series. For notices of future live and on-demand webinars as part of this series, please email us at webinars@lexbe.com or follow us on LinkedIn. Also, we'd like your advice regarding our webinar series. Please complete the survey at the end of today's session. Helps us continuously improve this program and cover the digital forensic and eDiscovery topics that are most relevant to you. And with that, I'd like to thank you for attending. Be sure to follow Lexbe on LinkedIn and check out our YouTube channel so you'll be alerted to the latest podcasts and webinar episodes. And watch your inbox for an invite to our next webinar on best practices in eDiscovery, generative AI, and digital forensics. Take care.